Hi friends, welcome to all. In this video, we are going to solve this packet tracer activity. Configure extended IPv4 ACLs scenario 2. Before coming to this activity, friends, if you like to get any CCNA version 7 online classes or any project support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get this type of technical videos in future, consider subscribing and don't forget to enable that bell icon so that you will get notification message whenever we upload a new video. Back to this activity, here we can see addressing table. Coming to the objectives, in part 1 configure a named extended ACL, then in part 2 apply and verify the extended ACL. Here is the scenario. In this scenario, specific devices on the LAN are allowed to various services on servers located on the internet. So here we can see the instructions. First of all, we will go to part 1. Configure a named extended ACL. Configure one named ACL to implement the following policy. We will see those policies. Block HTTP and HTTPS access from PC1 to server 1 and server 2. The servers are inside the cloud and you only know their IP addresses. Okay, here we can see our PC, that is a PC1, and our server, that is server 1 and server 2 is inside this cloud, I mean inside this internet, and we know their IP address. And we have to block those services, that is HTTP and HTTPS from this PC1. That means PC2 and PC3 is allowed to access server 1 and server 2. Coming to our addressing table, we can see their IP address, server 1 IP address and server 2 IP address. Coming to other policies, block FTP access from PC2 to server 1 and server 2. Okay, from PC2 to these servers, we have to block FTP service. Then block ICMP access from PC3 to server 1 and server 2. They given a note. For scoring purposes, you must configure the statements in the order specified in the following steps. Okay, perfect. Step 1. Deny PC1 access to HTTP and HTTPS services on server 1 and server 2. Create a named extended IP access list on router RT1. Here we can see that router RT1. Okay, which will deny PC1 access to the HTTP and HTTPS services of server 1 and server 2. 4 access control statements are required. What is the command to begin the configuration of an extended access list with the name ACL? Yes, in global configuration mode, we have to start with IP access list. Then we have to specify it's extended. So we have to specify extended. Then we have to give the name for that, extended access list. So name they given us ACL. Perfect. So we will show that in RT1. Begin the ACL configuration with a statement that denies access from PC1 to server 1 only for HTTP, that is port number 80. Refer to the addressing table for the IP address of PC1 and server 1. So here they given that command, deny TCP host, then they given the IP address of PC1, then they specify the host, that is the IP address of that web server. So that we will get from our addressing table, equals 80. 80 means HTTP service. Coming to this RT1 CLI, press enter, enable conft, that means configure terminal. Here we can give the command IP access dash list. Then let me put a question mark so that we can see what is the next command. We can give extended. We have extended or standard. We will choose extended. Then again question mark. We can give either a number or a name. So as they specified, we will give the name. ACL. Then press enter. Then we have to give this command. We have to deny TCP a specific host, that source IP address, then a specific host, it's a destination, that is a destination host, its IP address, then equal 80. We can do that. So here we will give a deny. Let me put a question mark so that we can identify the next command to be given. We have to give a TCP, that is transmission control protocol. Again a question mark. We have to give the source address. Here we are going to specify a single source host. So we can give the command host. Then we have to specify the IP address of that source host. So we will put a question mark. And here we can see a source address. We can get the IP address from this PC1 and paste here. Space, we will put a question mark again, and we can see we have a destination address. Again we have a single destination host, hence we will give a host. Then we have to specify the IP address of that host, destination address. We can get that from our addressing table. It's here. Just I will copy this. Okay, coming back to RT1. Here we will give that space, again question mark. We will give a EQ, match only packets on a given port number, that is a WWW, or even we can give the port number. We'll put a question mark. We can give either WWW or even we can specify the port number. So here we can see they specified the port number 80. We can give that here 80. Next, enter the statement that denies access from PC1 to server 1 only for HTTPS, that is port 443. We have to give this command deny TCP host IP address of PC1, then again host this IP address of our server 1 EQ 443, that is HTTPS. So we can see it's the same like our previous command we given, only the change is in this port number. Instead of 80 we are going to give 443, that is for HTTPS. We will do that. Coming back to RT1 again, we can press up arrow from the keyboard so that we will get the history, the command we entered last. Here we can see the command we entered, that is deny TCP host EQ80. So here we will change this port number 80 to 443. Then press enter. Otherwise you can type the entire command, not a problem. You have to type deny TCP host, right? This is just a shortcut. Enter the statement that denies access from PC1 to server 2. Okay, previously we done for PC1, from PC1 to server 1. Now we are going to do from PC1 to server 2. So here we have to change this destination host IP address. Okay, only for HTTP. Refer to the addressing table for the IP address of server 2. Here we can see the IP address of server 2. We have to change this, we have to give this address. Coming to RT1, again we can press up arrow here. We can press 2 times so that we get EQ80. Here we have to change the IP address of this destination. Here we have to give the IP address of server 2. We already copied it. Just paste it here. Then press enter. Then enter the statement that denies access from PC1 to server 2 only for HTTPS. That means we have to change the port number from 80 to 443. 443 is for HTTPS. Deny TCP host, the IP address of PC1, then the destination IP address EQ443. Okay, we can do that. Coming to RT1, we can press up arrow once so that we'll get the previous command we entered. Here we will change this 80 to 443, then press enter. Otherwise, we can type this entire command, deny space TCP space host space, like this. Now we will go to step 2, deny PC2 to access FTP services on server 1 and server 2. Refer to the addressing table for the IP address of PC2. Then enter the statement that denies access from PC2 to server 1 only for FTP. Port number is 21. So we have to deny TCP host. We have to give the IP address of PC2. Then again destination host, its IP address EQ21. We can do that. Coming to RT1, here we will deny TCP, specify the host IP address. We can get either from the addressing table or from this topology itself. So here I will copy its IP address and we can paste here. Then again host, the IP address of server 1. Copy and paste here, or you can type it. Then we will give a EQ, then the port number. We can see 21 is for FTP. We'll give you a 21. Enter the statement that denies access from PC2 to server 2 only for FTP, port number 21 only. Here we have to change this destination host IP address. We have to give the IP address of server 2. We can copy that. Then coming to RT1, here also we can use the shortcut, press up arrow from the keyboard. Then here we can change this destination host IP address to the IP address of server 2. Then press enter. Now coming to step 3, deny PC3 to ping server 1 and server 2. Refer to the addressing table for the IP address of PC3. Enter the statement that denies ICMP access from PC3 to server 1. We have to give deny, and we can see here we given ICMP. Then we have to specify host, then PC3 IP address, then specify host, then the destination IP address, the IP address of our server 1. We will do this. Coming to RT1, deny ICMP host. You will get the IP address of PC3. We can get it either from addressing table or from this topology itself. Okay, we'll copy this address. Then we have to specify the destination host IP address, the IP address of our server 1. Okay, then press enter. Enter the statement that denies ICMP access from PC3 to server 2. So here we have to change this server 2 address, otherwise we can see it's the same, deny ICMP host IP address of our PC3. Okay, we will get server 2 address. Then coming to RT1, again you can use a shortcut, press up arrow from the keyboard, and here we have to change this destination host address, server 2 IP address, then press enter. Perfect. Now we will go to step 4, permit all other IP traffic. By default, an access list denies all traffic that does not match any rule in that list. Enter the command that permits all traffic that does not match any of the configured access list statements. Okay, we will give that command in RT1. Here we will permit other traffic. We have to give a permit. We can give IP any. Step 5. Verify the access list configuration before applying it to an interface. Before any access list is applied, the configuration needs to be verified to make sure that there are no typographical errors and that the statements are in the correct order. Yes, we must do that. To view the current configuration of the access list, use either the show access list or the show running config command. Okay, we can use the show access list command. Coming to RT1, we will give end show access list. And here we can see the extended IP access list ACL, and here we can see the policy we set. This is the line number. Even we can verify using show running config, and we can filter it using this pipeline begin access list. So we will give this command. Coming to RT1, and here we can see the details. IP access list, extended ACL. Here is a note. The difference between the output of the show access list command and the output of the show running config command is that the show access list command includes the sequence numbers assigned to the configuration statements. These sequence numbers enable the editing, deleting, and inserting of a single lines within the access list configuration. Sequence numbers also define the processing order of individual access control statements, starting with the lowest sequence number. Yes, that's correct. So we cannot see that line number here in this show running config command, but here we can see in show access list command we get this line number also. Okay, now we will go to part 2, apply and verify the extended ACL. The traffic to be filtered is coming from the 172.31.1.96/27 network and is destined for remote networks. Appropriate ACL placement depends on the relationship of the traffic with respect to RT1. In general, extended access list should be placed on the interface closest to the source of the traffic. Yes, coming to our topology, here we can see our source devices. Here we can see the network 172.31.1.96. That means these three PCs, PC1, PC2, and PC3. They are the source devices. Step 1. Apply the ACL to the correct interface and in the correct direction. They given a note. In an actual operational network, an untested ACL should never be applied to an active interface. This is not a good practice and can disrupt network operation. Okay, on which interface should the named ACL be applied and in which direction? We can apply the ACL we created for this interface, that is G0/0, and it's in the in direction. Enter the configuration commands to apply the ACL to the interface. We will do that. Coming to this RT1, we will go to that interface, conft interface G0/, once more I will verify that interface. It's a G0/0. Then we can apply the ACL, apply access group. Let me put a question mark, and we can see we have to specify the access list name. It's ACL. Then we have to specify the direction. Again, I will put a question mark. We have in and out. So here we will give inbound packets, that is in. Step 2. Test access for each PC. Access the websites of server 1 and server 2 using the web browser of PC 1. Use both the HTTP and HTTPS protocols. Use the show access list command to view Which access list statement permitted or denied the traffic? The output of the show access list command displays the number of packets that match each statement since the last time the counters were cleared or the router rebooted. Also, we can clear these counters on an access list. We have to use this command, clear access list counters command. Now we will access the website of server 1 and server 2, which is inside this internet from this PC 1. First of all, we will get the IP address of server 1. Coming to PC 1, we will go to web browser, and here we can paste that IP address. So we can see the protocol, it's HTTP, and we can see it's request timed out. Just I will copy this, then close it. Again we will open web browser. We will try for HTTP yes. So here we will give yes, then press enter. So we will see whether we are able to access that web page. We can see request timed out. Now we will copy the IP address of the server 2. Coming to PC 1, web browser, paste that server 2 IP address, then click go. And actually this PC 1 is denied to access this HTTP service, request timed out. Now we will copy this, then close it again or reopen this web browser and change this URL, service change it to HTTPS, then click go. And port number 443 is also not allowed to access. Here we can see request timed out. PC 1 is denied to access HTTPS service also. Okay, here we will give this command show IP access list, and we can see the matches. Exit, show access list, right? We can give a show IP access list. Okay, and here we can see the matches. Access FTP of server 1 and server 2 using PC 1. The username and the password is Cisco. Okay, here we are going to access FTP of server 1 and server 2. We denied this FTP service only from this PC 2. So PC 1 must get this FTP service. We can try it. Just I will copy this address. Coming to PC 1, we'll go to command prompt, and here we can give FTP, then server address. So we can see username is Cisco, password also Cisco. Yes, we can access the FTP service from server 1. Now we will try to server 2 from PC 1. Quit, and here we will give FTP IP address of server 2, Cisco, password also Cisco. Yes, we able to access FTP from server 2 also. Then ping server 1 and server 2 from PC 1. PC 1 is allowed to ping to server 1 as well as server 2. Actually PC 3 is denied to ping to server 1 and server 2. Anyways, we will ping to our servers. Here is server 1 IP address. We'll go to command prompt, ping to server 1. It should succeed. Perfect. Now we will get the IP address of our server 2. Copy and ping to server 2. Perfect. Here we will give this command again, show IP access list, and here we can see that the matches. permit IP any 30 matches. Repeat step 2A to step 2C with PC2 and PC3 to verify proper access list operation. Okay, so we will get the IP address of server 1. We'll go to PC2, web browser, go, and here we can see we are able to access HTTP service. Now we will try HTTPS. We will edit this URL to HTTPS. Then click go. Be able to access this web page. Now we will go to command prompt and we will try FTP to server 1, and actually this is denied. We can see FTP request could not find host. Please check the name and try again. Now we will try to ping to server 1 and it should succeed. Oh, I'm sorry. Here we should remove this HTTP. We will give only the IP address. Yes. Now we will copy the IP address of server 2. Then coming to PC2. We'll go to web browser. And here we are able to access the web page. Then again we will reopen web browser for HTTPS. We have to edit here. Then click go. Okay. Now we will try to access the FTP of server 2. And here we can see trying to connect. We get some error opening FTP, disconnecting from FTP server. We will ping to server 2. It should succeed. Here is the IP address. And we get the replies. Here, as per the access control list, PC2 is not allowed to access FTP from server 1 and server 2, but PC2 can access the web page and also it can ping to server 1 and server 2. Now we will try from PC3. We'll get the server 1 IP address. Coming to PC3, we will go to web browser. We should get the web page. Okay, so now we'll try HTTPS. Reopen the web browser. Here we will edit to HTTPS. Perfect. Next we will try to access FTP service to this server 1. And the username is Cisco, password also Cisco. Yes, we are able to access it. We will try to ping to server 1. It should succeed. No, it will not succeed because we created the access control list to deny this ICMP. We can see it says a destination host unreachable. It's not working. Let me get the IP address of server 2. Coming to PC3 web browser, we should get the web page from this server 2. Now we will try HTTPS service. We should get the web page. Edit HTTPS. Go. We'll try FTP. FTP to server 2. It should succeed. So here I have to give only the IP address. Cisco. Password also Cisco. Be able to access FTP service. Now we will try to ping to server 2 and it should fail. Ping to this server 2. And here we can see destination host unreachable. Okay, just we will give this show command. Show IP access list. And here we can see the matches. Also we can clear these matches using this command. Clear access list counters. Okay, here I have to give clear access list counters. Now we will try this command, show IP access list, and we cannot see any matches. Okay, perfect. That's all in this activity, that is configure extended IPv4 ACLs scenario 2. Here we can see our completion status 100%. Now dear friends, if you have any doubt or any suggestions, you can comment below, or you can contact our team using our website. Link you will get from the description below. If you like our video, give a thumb and share with all your friends. Stay tuned. We will meet again with the next video. Thank you.